Black holes, the most mysterious, most powerful, and most terrifying objects in the entire universe. They can tear apart stars, bend space and time, and nothing that enters can ever escape, not even light itself. But what exactly are black holes? How do they form? What happens if you fall into one? And could one destroy Earth? Today we're answering every question you've ever had about black holes. This is the complete guide. Let's dive in. Let's start with the basics. A black hole is a region of space where gravity is so strong that nothing can escape it. Not matter, not energy, not even light. That's why it's black. No light can get out for us to see. But black holes aren't empty voids sucking up everything like cosmic vacuum cleaners. They're actually incredibly dense objects. Imagine crushing Earth down to the size of a marble. That's the kind of density we're talking about. At the center of a black hole is something called a singularity, a point where all the mass is concentrated. It's infinitely small and infinitely dense. Our physics literally breaks down here. The boundary around a black hole is called the event horizon. Cross this line and you can never come back. It's the point of no return. Here's the question everyone asks. What would happen if you fell into a black hole? First, you'd experience something called spaghettification. The gravity at your feet would be so much stronger than at your head that you'd be stretched like spaghetti. For a stellar black hole, you'd be ripped apart long before reaching the event horizon. But for a supermassive black hole, you might actually survive crossing the event horizon. At first, here's where it gets weird. From your perspective, you'd cross the event horizon and fall toward the singularity in minutes. But to someone watching from outside, you'd appear to slow down and freeze at the event horizon forever. This is because time itself slows down near a black hole. At the event horizon, time essentially stops from an outside perspective. This is Einstein's theory of relativity in action. And once inside, no one knows for sure. You'd reach the singularity eventually, but what happens there is beyond our current understanding of physics. Black holes don't emit light, so how do we know they exist? How can we see them? We detect them by watching how they affect things around them. Stars orbiting invisible objects, X-rays from superheated accretion disks, gravitational waves from colliding black holes. In 2019, scientists achieved something incredible. They captured the first ever image of a black hole. This is M87 star, a supermassive black hole 55 million light-years away. It took a network of telescopes across the entire planet working together to capture this image. That orange ring? That's photons orbiting just outside the event horizon. The dark center is the black hole's shadow, the event horizon itself. In 2022, they revealed an image of our own galaxy's supermassive black hole, Sagittarius A star. We're living in an era where we can finally see these cosmic monsters. Now let's answer some of the scary questions. Could a black hole destroy Earth? The good news, the closest known black hole is about 1,500 light-years away. It's not coming for us anytime soon. But what if one did approach? Black holes don't actually suck any more than any other object with the same mass. If you replace the sun with a black hole of the same mass, Earth would keep orbiting normally. We just freeze to death without sunlight. Could the Large Hadron Collider create a black hole? Technically, yes, but it would be so tiny it would evaporate instantly through something called Hawking radiation. Stephen Hawking discovered that black holes aren't completely black. They emit radiation and slowly evaporate over trillions of years. Could you use a black hole for time travel? Theoretically, yes. Orbiting close to a black hole would cause time to pass slower for you than for everyone else. You could travel to the future. So what's next for black hole science? We're building better detectors for gravitational waves, ripples in space-time created when black holes collide. LIGO has already detected dozens of these mergers. Scientists want to image smaller black holes, study their jets that shoot matter at nearly light speed, and understand how they shaped the early universe. Some physicists even speculate that our entire universe could be inside a black hole. Wild, right? Black holes challenge everything we know about physics. They're where Einstein's relativity meets quantum mechanics, and we still don't fully understand what happens at that intersection. So here's what we know. Black holes are the universe's most extreme objects. They're born from dying stars or grew over billions of years at galaxy centers. They warp space and time. Nothing can escape once you cross the event horizon, and we've finally learned how to see them. They're not cosmic vacuum cleaners hunting us down. They're natural consequences of gravity taken to its extreme. They're laboratories where the laws of physics are pushed to their breaking point. And the most fascinating part, we're still learning. Every observation reveals new mysteries. Black holes might hold the key to understanding reality itself. From the event horizon to the singularity, from Hawking radiation to time dilation, black holes remain the ultimate cosmic mystery, and that's what makes them so incredible. Thanks for watching Factology. If you want more deep dives into the universe's biggest mysteries, subscribe and let me know what topic you want next.